This week, we will present construction period, site analysis, and construction engineering. The first is the construction period. Excavation began in March 1993. Construction began in March 1994 with the completion of excavation work and the foundation of the first tower. In May 1995, the completed sky bridge arrived from Korea. In February 1996, a ceremony was completed for both towers. In March 1996, spires for both towers were installed. In April 1996, the Petronas Twin Tower was officially declared the tallest building in the world. As such, excavation and foundation construction alone took a year. The Petronas Twin Towers were built by Samsung in Korea and Hajama in Japan. At the time of the bidding, Samsung failed to meet Malaysia's requirement of building experience with more than 50 stories and conducted a consortium with Gukdong Construction, which had experience in building the 53-story Korea General Trade Center. On the other hand, Japan's Hajama Company was a world-class construction company, including the construction of the Gyeongbu Line and the dam. In addition, Samsung took over 35 days and started late. Samsung has set up a construction schedule every 5 days to raise the building faster than Japan. To this end, Samsung introduced a method called self-climbing foam. The first method Samsung introduced was to use 11 pumps with 10 horsepower capacity without a tower crane. Through this method, tower cranes were able to achieve positive loads, reduced frequency of use, and reduced process. "40 days before the sky bridge construction in Korea's Hanpung department store collapsed. This incident has led to Korean construction companies becoming the epitome of poor construction, and supervisors had a problem of distrusting Samsung's proposed construction methods. Excavation started in March 1993 after developers shifted the whole site 60 meters southeast of where it was initially designed to be. Drilling had shown bedrock irregularities at the site that would have made supporting the immense weight of the buildings an almost insurmountable challenge. So with a newly fixed site a quick stroll away, a massive foundation was excavated, each 21-meter depth easily capable of shallowing a 5-story building. During the height of excavation work, some 500 truckloads of earth were removed every night. The second is the site analysis. The original site was a plain, used as a Serenger turf club and a horse racing track. Therefore, it was judged that there was no problem with the land at the time of design. The site is located on two different ground boundaries, Kenny Hill and Kuala Lumpur Limestone. Drilling work confirmed the steep slope of the rock from 80 to 180 meters over the site. In particular, the height of the rock at the first design location of the towers were greatly changed, which could lead to floating subsidence if construction was carried out. To solve this problem, the location of the building had to be moved 60 meters southeast of the Kenny Hill foundation. This is because the Kenny Hill ground thickness at the location could support the building's load. A depth of 10 to 20 meters is a weak alluvial layer of clay or sand. This location consists of the base of various thickness of sedimentary layer formations such as silt and sandstone. In addition, the interface is always overlapped by an irregular slump zone in which the Kenny Hill material is soft and erode jointly with limestone. So it is not suitable as a foundation. Therefore, the friction piles were set different heights depending on the shape of the Kenny Hill, avoiding the slump zone. The last is the construction engineering. The Petronas Twin Towers had a total of 600,000 tons of buildings and a base weight of 35,800 tons, so ground testing was very important. Therefore, 260 pressure meters test for soil and soft rock ground deformation using expansion of cylindrical flexible membranes under pressure, and two fully instrumented 3,500 pile load tests were conducted. As a result, each tower had a pressure of 1,140 kilopascal, more than twice the capacity of the Kenny Hill soil layer, which could lead to basic collapse. So, to avoid this possibility, the foundation used a large concrete-filled pier foundation. Two holes were placed under each pier to fill the concrete, and more were placed under the core wall. The pier also perforated the base cancer before it was subjected to the soil pressure. As a ground survey, a boring test was conducted to collect samples for soil distribution, stratification, and soil test on the ground above 200, and a probes was conducted from the center of 8 meters of the foundation of 200. As a result, a number of buoys were found in the limestone layer, and extensive grouting was carried out before the pile construction was carried out. A total of 104 rectangular friction piles of the 1.2 meters multiplied by 2.8 meters were excavated at the length from 40 meters to 105 meters from the foundation floor. Afterward, bottom method was used to excavate underground wall construction equipment and carried out base construction. Barrett construction was carried out by workers putting box-shaped structures made of reinforcement into holes in each file filled with concrete. Friction between files and sand has been augmented by injecting grout, a mixture of sand cement that has already been introduced into a pipe installed on the outside of the file surface. As the grout hardened, friction of the outside of the body increased. Eventually, each foundation was constructed with a mat layer on the top of barrette, and the foundation was completed. Today, we learned about the method of excavation, the various methods of foundation, and the importance of ground testing on the Petronas Twin Towers. Next week, we will learn about the construction of the Petronas Twin Towers. Thank you.